Hi students. Okay, in this video, we're going to prove a logarithm questions as given in our slide. So let us move on to the question. Okay, so since it's a show that question, so we have two sides. Can you see this is your left hand side. This is, we call it left hand side. And this part is called a right hand side. Okay, right hand side, left and right. Okay, as I told you before, you can choose any side of the equation and then prove to another side. For example, you choose left hand side, you can prove to the right hand side, or you can take a right hand side and prove to the left hand side. Or another way, you can reduce both sides and prove them equal at one point. Okay, so normally I will advise my students to take a complex side, which is more easier. So in this equation, the complex side is actually on your right hand side. Okay, this is a complex side. Okay, so let us start from right hand side. Okay, let us start from right hand side. Okay, so here we have 2 plus log a bracket 1 plus 2b over a plus b square over a square. Okay, my first approach is I'm going to change the entire bracket in here as a single fraction. Okay, hope that you can do that, huh? Single fraction. So what I can do here, this is actually over 1. Okay, we're going to change everything. The denominator is a square. So here you need to times with a times with a. So here you need to times with a square and times with a square. Got it? So you're going to have a single fraction inside the bracket. So you have, okay, this one, okay, these two, what I'm going to do, I'm going to insert log AA. Okay, you can do that because log AA here is represent 1. So we never change the value of the 2. Plus log A bracket, this whole thing going to be a single fraction, that is A square plus 2AB plus B square over A square. Okay, hope that you understand, huh? Okay, we already done all the, what do you call, making them a single fraction. Okay, done. So now if you look at here, this one, this particular part here is actually, this is a came from the expand of A plus B square. If you can understand, you can try to expand this one. You will get A square plus 2AB plus B square. So that means this whole thing can be factorized as a plus B square. Understand? Okay, so we're going to factorize. So I'm going to bring the 2 up here. Okay, so you will get log, you're going to get log A square plus log A. So I'm going to put a big bracket, easy for you to understand. So this whole thing I'm going to factorize as A plus B square over A square. Understand? Okay, got it done? Okay, done. Then after that is going to, you're going to get log A with A square plus, okay, this one, this particular log, we going to, what do you call it, we're going to, no need class, no need actually, we can combine this, we can directly combine. That means because plus, when you combine, it's going to be times, right, multiply. So you're going to get log A, this whole thing I'm going to combine as 1. Why you can combine? Because everything is already under base, under log A, under log base A. So A square, you see A square, the plus here is going to be times with this entire here. Understand? Okay, so it's going to be A plus B square over A square. So you can cut this out. Okay, so we have this log A with A plus B square. So this is equivalent to your left hand side. So it's shown. Okay, try to view the video a few times to get a clear understanding. So in log, the plus can be combined as times and the minus can combine as a divide. Understand? Huh? The minus can combine as a divide. So what I did here, I take this one and this whole thing, this one. So maybe I can highlight for you here. So I take this whole thing here. Okay, this whole thing combined with this. Combine with this. Okay, we combine. Okay, so when you combine means combine in case combine here is the because of the plus is going to be times here. Can you see times here? So that's why a squared times with this whole thing. Understand? Okay, so done. So this is your answer for this question, class. Thank you.